About dividing decimals. The first section is dividing an amount by a whole number and getting a decimal answer. The very first one that we're going to focus on is 13/4, which means 13 divided by 4. Oh, wait, I got to put my little marker thingy on, I think. Oh, golly gee. Is that going to work? All right. So 4 is going to go on the outside. 13 goes on the inside. Because I'm recording it, I'm going to probably not use names as much as rudely point at you when I want you to help out with various parts of the procedure. You might have noticed that when you watch YouTube videos that I don't say names, or I try not to. So the first step is to say how many times 4 goes into 1, but it doesn't, so we go another digit over. And how many times does 4 go into 13? 3 times. Because 3 times 4 equals what? 12. And when we subtract for sister's subtract step, what do we get? 1. But since we're in the decimal section and we're focused on decimal, if we're asked to make a decimal answer, raise your hand if you remember how to make a decimal answer out of the remainder, how to keep it going in order to get a decimal answer when there is a division problem that doesn't work out evenly. Yes, ma'am?
You add a 0?
Well, a little bit more than that. You add... if I add a 0, then 13 isn't 13 anymore. It's 130. So what do I need? I can't change 13 to be 130. There's no decimal point right now. But you're going to have me. Everybody's like, make a decimal. Make it a decimal. Make it a decimal. Right? So you can't add a 0 if there's no decimal point. I personally put the decimal point in my answer at the same time that I'm putting it in the problem, or as I encounter it when I'm working through the problem. Now I can tack on the 0 like she said so that I can keep on dividing. So how many times does 4 go into? Now that's a 10. 2 times. Because 2 times 4 equals what, sir? 2 times 4? 8. It's so messy. I lost my stylus pen sometime over the summer, 1 or 2 summers ago. I don't think it was this past summer. Anyway, I digress. It still didn't work out evenly. So what do I need to do?
Add another 0.
Add another 0 to bring down. And how many times does 4 go into 20? How many times does 4 go into 20? 5 times. And you can finish it up and do the 5 times. 4 is 20. 20 minus 20 is smiley face. Or you can go, it's going to work out, so I'm done with that one. So that was a little reminder about how to make a decimal answer out of a whole number division problem if we want a decimal answer. Uh-oh. Snap. Now I want to move this over. I think I got to do that. There we go. The next problem already has a decimal in the dividend. So in this particular case, we're going to set up our long division again. I don't know if I really have to do this every time. Clearly I don't use this software very much. We're going to put the 8 on the outside of the long division, the 15 and 2/10 on the inside. It's supposed to be a decimal point, really is. So 8 doesn't go into 1, so we look at 2 digits instead. 8 goes into 15 how many times?
Once.
1 time. Because 1 times 8 equals what?
8.
It equals 8. It's like, that's me on recording. That may or may not end up on YouTube. We'll see. All right. Now sister tells us subtract. And when we do 15 minus 8, we get 15 minus 8 equals? 7. Now at this point, I'm about to encounter that decimal point that's under the long division stuff. Go ahead and put it right above in your answer. That's why that first time when we started coming into school and reviewing stuff and we did long division, we said make sure everything's staying lined up. So your decimal point now should go up there because that's the point where we're at. We're literally at the point of the point. So, now we did the sister subtract. And what's going to be the next step after sister subtract?
We put down the 2.
Yeah, we bring down that 2. We do the brother bring down. So, you, sir, in the back corner, how many times does 8 go into 72?
9.
9. Even though it really represents 7.2 or 7 2/10, with the long division process, once you put your decimal point up there in the answer, you don't have to worry about your place value, just like when we were in big numbers, big place values. And again, you could do 9 times 8 is 72, 72 minus 72, smiley face, or you could just go, I know that's going to work out, plus Mrs. Rowe doesn't have room on their space. It doesn't always work out evenly, even if the decimal point was already there like this one. Shh, I'm getting dizzy, it's moving back and forth. All right. Sometimes you have to add the decimal point like we did in the first one to make a decimal answer. I usually wouldn't. I would make a mixed number answer. It would be easier unless it's specified I had to have a decimal answer. But if the original problem has a decimal in it, then that means we have to have a decimal answer. So in this one, we're going to do 6 on the outside, 2 and 19 hundredths on the inside. So how many times does 6 go into 2 closest without going over? How many times does 6 go into 2? Just the 2.
Oh,
None. I do put the 0 up there even though it's optional. Then I put the decimal point before I go ahead and go, okay, I'm looking at 2 digits instead. So I'll go back to you. How many times does 6 go into 21? 3. Because 6 times 3 equals what? 18. And now we do sister subtract. 21 take away 18 is what? 3. So you don't worry about the fact the decimal point was there, just like we didn't worry about the fact whether we were in the thousands place or the hundreds place. Shh. So just 3. Now we are going to make sure 3's good. Wasn't too much left over. So now that we made sure 3 is okay, sister's step is over. And so what are we going to do next?
Bring down the 9.
Bring down the 9. All right. How many times does 6 go into 39 closest without going over?
6.
6. Because 6 times 6 equals what? 36. And then we go ahead and we do that subtraction. 39, take away 36, leaves us with what in the back?
It's 3.
It is 3. So now what do we need to do because it didn't work out even and I ran out of digits?
Add a number 0 to the...
Now because we're already on the other side of the decimal point, that's the difference between this one and the first one. We're already after the decimal point, we can just tack on a 0 like we wanted to do the first time but had to put the decimal point on first. So we can bring down a 0 if we're already after the decimal point. And to finish up this problem, how many times does 6 go into 30 without going over in the back? 5. And that's when it's going to work out evenly because 5 times 6 is 30. And look, I'm circling my answers like I was supposed to do on last night's answer key. Well, ovaling. I'm ovaling my answers. Those are totally not circles. Okay. Shh. But if your original problem was dividing by a decimal, you had a decimal on the outside of the long division. The divisor was the one with a decimal point. That is considered a pesky decimal. If you had a decimal inside the long division, your dividend had a decimal, no problem. But if there's a decimal point on the outside, then we want to swoop it away. We want to multiply by 10 or multiply by 100, and essentially, that's going to change the problem, unless we also multiply the other number by the same amount. So it's just like making equivalent fractions. If I had 2/5, it's going to be the same as 20/50. It's going to be the same as 200 500ths. So multiplying by a bunch of multiples of 10 won't change the end result if I do it to both my divisor and my dividend. But I only need to do it if it's the divisor that has the pesky decimal. Question, sir?
So if you swoop them away, would you have to unswoop them?
No.
Answer?
So that's the big difference between multiplication and this. In multiplication, you ignore them, and then at the end you unignore them. In this, you just take care of them right away. You get rid of your pesky decimal, but you make an equivalent division problem just like making equivalent fractions. So when you had 2/5, you can make 2/5 into 20/50ths by doing times 10 times 10. It's the same thing because the division setup is the same as the fraction setup. So we're going to jump to that. I hope we'll see. So to divide by a decimal, I think I have to make it bigger a little bit at least. Those lines are teeny tiny and my fingers are not that tiny. All right, let's see if I can write in there. To divide by a decimal, we are going to move the decimal point in the divisor enough times to the right. Makes the places get bigger to the left. You know, I have my left-right issues. To make the divisor a whole number, and we are going to move the decimal point. I cannot write that whole word in there, so I'm going to write decimal and then PT for point. Not physical therapy, but point. In the dividend, the same amount of times, ooh, that's messy, to the right, to make sure you get the same quotient as the original problem. Oh, I really now wish I had thought about getting my stylus back. I have one at home, but I do not have one here at school, not anymore. Or I do, but I don't know where it is. I've checked all the shelves, I've checked all the closets, just can't seem to find it. All right, so let's reiterate what that says so I can make sure I didn't mess up any of the wording, and you can try to fill in anything you weren't able to write in because of the chicken scratch. Move the decimal point in the divisor enough times to the right. Yes, I got it correct. To make the divisor a whole number, and move the decimal point in the dividend the same amount of times to the right to make sure you get the same quotient as the original problem. I did it, yay! Next step is divide as usual. Make sure you're carefully dividing, showing all the steps and keeping things lined up. And then also you make sure that if there is a decimal point, point. Oh, this is bad. This is very, very bad.
Can you erase it?
Probably. Put the decimal point in the quotient directly above. I might try this again when I do it in standard math to try to get a stylus working here. Above the decimal point in the dividend. So the little simple example there is if you have 15 divided by 2.5, you can just swoop the 2.5's decimal one place to make it 25, and therefore swoop the other decimal point, the implied decimal after the number 15, so that you divide 150 by 25. And how many 25s are in 150? Wait, back to my sticks. Not that one, she's not here. Back to my sticks.
That's
6. Just like there are 6 sets of 2.5 in the number 15. So let's practice with these examples. Actually, I wonder, I'm going to pause it. I'm going to let you try out the problems, and then we'll fill in the answers. So go ahead and try out the 4 problems. Instead of swooping before you even set it up, to avoid over swooping, set up your long I'm not in marker mode. Set up your long division first, and that will prevent you from possibly over swooping. So that will make it so that you can't swoop beyond where the long division symbol is. So I will go swoop, swoop, and then this one swoop, swoop to make it equivalent, and my decimal point will end up there. On the second one, I set up the long division, 0.7 or 7/10 is on the outside, 0.91 or 91/100 is on the inside. I only need to do a single swoop because it's only the 0.7 or the 7/10 that's pesky. And then I do a single swoop here, swoop, so it's 9.1 or 9 1/10 that I'm dividing 7 into. So if you set up your long division first, it will help you from over swooping. Versus the third example, 0.014, so 14 thousandths, I believe. And then 4 9/10, so 4.9 inside. Swoop, swoop, swoop. I do need to do 3 swoops. So over here, swoop, swoop, swoop. I'm not prevented from doing that because I have space to put those placekeeper zeros to make it 10, 100, 1,000 times bigger to get rid of the pesky decimal. I'm going to do the last one's setup, and then you can do the actual long division part of it because the setup is the part that's kind of new. I will zoom this out so you can make sure that yours are set up appropriately. So this one, swoop, swoop. So this one, swoop, swoop. Decimal points here. I'm going to shrink this a bit so you can see and make sure yours are getting the decimal points in the correct locations. And then I'll pause it for you to do the long division work. So the important new part of this is the swooping, which we just did and we put it on there. Everybody's doing the long division or finishing up. We're going to do that on the board, not on the iPad. And make sure we have the decimal in the answer appropriately. Maybe at the end we'll just stick the answers on the iPad's version. So after doing the work, the first one's final answer, I gotta put my marker on, is 85. Do not then do any type of swooping with that. That is the final answer. We took care of all the swooping up front. The second one's final answer ended up being 1.3. So we did all the swooping up front. There's no swooping to do at the end. Make sure the decimal point got lined up nicely, though. I'm going to pause it again to get 2 more participants up to the board. For the last 2 problems, make sure you have the 3 is over the 49. The 5 is when you brought down that 0. And then another 0 because you do have to go all the way to that decimal point. And that's the final answer on that one. And on the last one there, you had 8 went into 19 twice. And then when you had 3 and you brought down a 2, that went in 4 times. But then when you brought down the 5, 8 went into 5 0 times before you brought down another 0. Oops, decimal point, I kind of lost it a little bit. And then it went in 6 times, then 2 times, then 5 times. So make sure you are carefully going digit by digit.